G'day, welcome to Accelerate Maths. Today we'll learn how to convert ordinary decimal numbers to binary numbers. Binary numbers are used in computer code and are based on the number 2. First, let's look at other number systems that you already know. In baseball, runs are recorded using a tally system like this: 1, 2, 3, 4 and 5, and then we start again: 6, 7, 8, 9 and 10. This tally system is based on the number 5, like the number of fingers of one hand. Now let's see our ordinary decimal system that is a base 10 number system. We count 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And then we start again: 11, 12, 13, up to 20 and so on. The position of the units or ones, the tens, the hundreds, the thousands column is important. Another way of considering the value of each column is to write them with 10 as the base number and with exponents. 1000 is 10 cubed, or 10 to the exponent of 3. 100 is 10 squared, or 10 to the exponent of 2. 10 is 10 to the exponent of 1, and 1 is 10 to the exponent of 0. Let's see some examples of the decimal system. The number 1 has a 1 in the units or ones column. The decimal number 10 has a 1 in the tens column and a 0 in the units column. 11 has a 1 in the tens column and a 1 in the units. 12 has a 1 in the tens column and a 2 in the units. 30 has a 3 in the tens column and a 0 in the units. 100 has a 1 in the hundreds column and zeros in the tens and the units column. 6000 has a 1 in the thousands columns and zeros in the rest of the columns. Notice that we consider the value of the numbers from left to right. Now for the binary number system. It's a base 2 number system. Computers are electrical devices where individual parts are either switched on or switched off. In binary, we write a 1 for on or present and a 0 for off or absent. Binary numbers are written from left to right. In this binary number system table, notice that the column headings are multiples of 2. They are also written with 2 as the base number and with exponents. 8 is 2 cubed, or 2 to the exponent of 3. 4 is 2 squared, or 2 to the exponent of 2. 2 is 2 to the exponent of 1, and 1 is 2 to the exponent of 0. Let's do some examples. The number 1 in ordinary or decimal numbers is only a 1 in the multiplied by 1 column. In binary, we say 1. The number 2 in ordinary or decimal numbers is only a 1 in the multiplied by 2 column, followed by a 0 in the multiplied by 1 column. In binary, we say 1, 0. The decimal number 3 is equal to 2 plus 1. So in binary, we write a 1 in the times by 2 column and a 1 in the times by 1 column. In binary, we say 1, 1. 4 is only a 1 in the times by 4 column, with zeros in the rest of the columns. In binary, that's 1, 0, 0. 5 is equal to 4 plus 1, so we write a 1 in the times by 4 column and a 1 in the times by 1 column. In binary, that's 1, 0, 1. 6 is equal to 4 plus 2. We write a 1 in those columns to indicate their value is present, and zeros in the rest of the columns. In binary, we say 1, 1, 0. The decimal number 7 is equal to 4 plus 2 plus 1. As a binary number, that's 1, 1, 1. Let's see some more examples. For 8, we write a 1 in the times by 8 column and zeros in the other columns. As a binary number, that's 1, 0, 0, 0. 9 is equal to 8 plus 1. In binary, that's 1, 0, 0, 1. 10 is 8 plus 2. In binary, that's 1, 0, 1, 0. 11 is 8 plus 2 plus 1. In binary, we say 1011. 12 is 8 plus 4. In binary, we say 1100. 13 is 8 plus 4 plus 1. In binary, that's 1101. The decimal number 14 is 8 plus 4 plus 2. In binary, that's 1110. Now let's see some larger numbers. Remember that the columns are all multiples of 2, and remember that we go from left to right. The decimal number 85 is smaller than 256 and smaller than 128. But it's larger than 64, so we write a 1 in the 64 column. Now how much is left? 85 minus 64 is 21. 21 is smaller than 32, so we write a 0 in that column, but 21 is larger than 16, so we write a 1 in the 16 column. Now how much is left? 21 minus 16 is 5. 5 is smaller than 8, so we write a 0 in the 8 column. But 5 is larger than 4, so we write a 1 in the 4 column. How much is left? 5 minus 4 is 1. 1 is smaller than 2, so we write a 0 there. And then we write the 1 in the 1s column. 85 in the decimal number system is equal to 10100101 in the binary system. Here's our last example. The decimal number 293 is larger than 256, so we can write a 1 in the 256 column. How much is left? 293 minus 256 is 37. 37 is smaller than 128 and smaller than 64, so we write zeros in those columns. But 37 is larger than 32, so we write a 1 in the 32 column. How much is left? 37 minus 32 is 5. 5 is smaller than 8, so we write a 0 in that column. But 5 is larger than 4, so we write a 1 in that column. How much is left? 5 minus 4 is 1, so we write it there. 293 in the decimal number system is equal to 100100101 in the binary system.